Hello, my name is Kara Moore. I'm an assistant professor at Oklahoma State University and a 2019 to 2020 Project TIER Fellow. Project TIER was founded by Richard Ball and Norm Medeiros at Haverford College. The goal of Project TIER is to promote the integration of principles related to transparency and replicability into the research training of social scientists. TIER stands for Teaching Integrity and Empirical Research. Project TIER's mission is to promote systematic change in the professional norms related to transparency and replicability of empirical research in the social sciences. It's guided by the principle that providing comprehensive replication documentation for research involving statistical data should be as ubiquitous as providing a reference list. Authors should view their documentation as an essential component of how they communicate their research to other scholars. The goal of our workshop is to provide training on the TIER protocol. The TIER protocol is a standardized method of documenting your workflow from data processing to analysis. A large portion of Project TIER's mission is focused on teaching reproducibility. So today, after the workshop, the co-hosts will discuss their experiences in implementing the TIER protocol in their classrooms, and then we'll open the floor to a general Q&A. You can apply the TIER protocol both in your pedagogy and in your research. With regards to teaching, the benefits of Project TIER are really twofold. First, in the teaching of best research practices, and second, in having students document their work in a standardized way. This allows you as the instructor to more easily pinpoint problems. This, in turn, allows students to be able to perform better and learn research practices more easily. And as the instructor, it really helps you to more efficiently help your students through research problems. As a scholar, TIER provides a standardized method for reproducibility, and with large buy-in, it makes reproducing others' work easier.
Welcome to everyone, and depending on where you are in the world and your time zone, I wish you good morning, good afternoon, good middle of the night, as the case may be. I would like to begin by really very sincerely and warmly thanking Jack Arnold and Kara Moore and Jordan Waggy for organizing this workshop, to SIPS and everybody who made this year's unconference possible, despite many unexpected challenges, and in particular to Kara Moore for writing the SPSS syntax for the demo project that is going to be featured in this video. So this workshop and the hackathon this afternoon are about teaching reproducible research methods and writing curriculum for teaching reproducible research. This video sets the stage by highlighting the principles and practices that are going to be embodied in that teaching and the curriculum that we're writing. So it provides a model of what do we mean by reproducible research, so we have a clear idea of what we're trying to teach students how to do. And the way it illustrates those principles and practices is to go through a demo research paper that illustrates all the different pieces of the paper that make it reproducible. And by demo research paper, that means it's a little toy article. It's not an actual publication, but it's a purpose-built demo that's intended to illustrate all the key elements of documentation for reproducibility. And we'll have a look at that in just a moment. Just to give some very big picture building blocks that this is all built upon. So the foundations of making computations reproducible, the bedrock of it all is working in editable scripts. So typing commands into a script that you can run, edit, run again, and then when you're all done your project, you can save and share them with other people. And that's really the fundamental thing that makes the work reproducible. But it's more than just a matter of saving scripts. It really involves making a whole package of reproduction documentation, sometimes called a research compendium, in which that's where you save the scripts, but you also save data, supplementary information. And the idea is that with that research compendium, or with that folder full of scripts, data, and other information that the author of a study puts together, a third party should find it easy to independently reproduce all the results reported for a study. And by independently, that means not even needing to go back to the author to ask for help or ask for code or anything. Everything necessary should be right there in the research compendium that is archived or circulated with the manuscript. A comment on software. Fundamentally, all the ideas and methods and principles that we talk about in this video are software neutral in the sense that they can be implemented with many different kinds of software. So this demo project that we're going to look at could have been done with Stata or SAS or MATLAB, Python, many other possibilities. Perhaps notable to the psychology community is that this project could equally well be done with SPSS. The only limitation to this software neutrality is that the kind of reproducibility that we're going to talk about cannot be achieved if you're working in drop-down menus or interactively executing commands one at a time from the command line, because that doesn't leave you with scripts that you can save that somebody else can run. So it doesn't do the trick. So although there's this general software neutrality that as long as you can run your software with scripts as opposed to just interactively, all of this is software neutral. But when we get down to brass tacks and do a particular example to illustrate, well, then we've got to choose one particular software to use in the example. And in this case, the demo project I'm going to show you was done with SPSS. Although in a way it's a bit arbitrary, we could have used Stata or anything else. We really also want to make a special point about SPSS, which is that you can do top quality, high quality, reproducible research with SPSS. And I think that's an important thing for people to realize, because many times people will say something like, oh, I've been teaching with SPSS for a long time. I've always been teaching with point and click, but now I'm realizing I want to teach my students to make their research reproducible, so I'm going to have to use some other kind of software, like maybe R, maybe Python, maybe something else. But there's the idea that if you want to make your research reproducible, you have to abandon SPSS and use some other software. And the fact of the matter is, well, and also that can be discouraging to people. That can seem like a high bar to get over, to learn a whole new package, some of which have sort of steep learning curves. There may be people out there who are interested in doing reproducible research and teaching reproducible research methods, but feel like they've got to get over this big hurdle of learning R or learning some new package. And the message we want to send is you don't have to do that. If you would like to learn R, that's great. And you can do wonderful things with R. And that's very constructive and useful and an excellent approach to reproducible research. At the same time, if learning a new software package is holding you back from introducing reproducibility into your teaching, that doesn't have to be the case. You can do reproducible research with SPSS. And that's going to be illustrated by the demo project that we look at. Now, this is not to say that there's no learning curve. Indeed, if you've been exclusively teaching with point and click on SPSS, there is a step you've got to take, which is to transition from drop-down menus, point and click, to working with syntax files. And that involves learning a few concepts, tricks, methods, but that is a much lighter lift than learning a whole new software package. So the general orientation for this presentation is that on the one hand, we're illustrating procedures and principles that are software neutral and implementable with any package that uses programmable scripts or editable scripts. But it particularly is a model for SPSS users who are interested in making a transition from point and click to syntax files. Okay, so let's turn to the demo project. It is posted on OSF at the URL indicated here, and the whole project can be downloaded from there. And for some of the principles that are underlying the way that documentation was constructed, it's based on the tier protocol, which there's all the information about at the project tier website. But now let's turn to the project itself. Here's the manuscript of the paper for the demo project, titled Money, Happiness, and the Midlife Crisis. It's not a real research paper, but it does use real data from real sources, and the statistical results that it reports are based on real manipulations and analyses done with real data. But it's just packaged in this simple little demo paper that's intended to illustrate all the different components of the documentation. But let's first get acquainted with the paper. So it's got all the standard sections of a research paper: an introduction, some previous literature review, a section about the data. And the data come from two sources. One is the Pew Research Center Global Attitudes Project. This is a survey from 2002 of individuals in many different countries. That's one of the data sources. And the other data source is the World Bank World Development Indicators, which is a standard source of economic variables. In the Pew Research Center data set, there are two main variables that we take out of it. One we call status, which was each respondent's answer to a question about subjective well-being. They were asked to rate their subjective well-being on a scale of 0 through 10, 10 being the highest. And we call that variable status. And then another variable is age, which is each respondent's age in years. It's going to be helpful in the analysis to have a squared term for age. So we generate a new variable called age squared. So all of those variables are at the individual level, the different values for every individual in every country. The variables from the World Bank are GDP per capita and government consumption, and those are at the country level. So there's just one value for each country. And we're using the values for 2002, since that is the year that the Pew survey was done. And there's one more country level variable, which we call CM status, for country mean of satisfaction. And there's just one unique value for each country, which is equal to the mean of all the values of status for all the people in the country. So that's the description of the variables we use and where they came from. Then there's a section about descriptive statistics, and the only thing in this demo in the way of descriptive statistics is in Table 1. So let's go down and look at Table 1. There it is. And for each country, in the end, in this demo, we use just 7 of the countries from the Pew survey. And this table lists for each country what was the mean of the satisfaction ratings reported for all the individuals in the country, what's the income per capita of the country from the World Bank data, and what's government consumption as a percentage of GDP, also from the World Bank data. So that's the descriptive statistics section of this paper. Then we get to the analysis and results. And what do we have? So we have column 1 of table 2 and column 2 of table 2. And so both of those come from regressions. And let's look at table 2 to see exactly what is in there. Okay, so column 1 of table 2 is from they both are regressions with satisfaction as the dependent variable, and as explanatory variables have age and age squared. And the difference between the two regressions, the only difference is that in column 2, the regression reported here included country fixed effects, so dummy variables for 6 of the 7 countries. And just quickly, to get some intuition about this, let's look at column 1 for the regression without country fixed effects. So the coefficients on age and age squared are both highly statistically significant. And the salient thing to notice is that there's a negative coefficient on age and a positive coefficient on age squared, which means that if you graph the fitted values of satisfaction against age, that will be a U-shaped pattern. So it'll start at some level for young people. It will at first decrease down to some minimum point and then start increasing afterwards. That's because of a negative coefficient on the linear term and a positive coefficient on the squared term. And we have the same thing when we do the regression with country fixed effects. We have the same thing, negative coefficient on age, positive coefficient on age squared. So again, in both cases, this is suggesting a U-shaped relationship between satisfaction and age. So the natural question to ask then is, if there's this U-shape with subjective well-being first declining with age and then eventually increasing with age, where does that turnaround point come? What's the age at which subjective well-being reaches a minimum and then begins to increase again? And using these coefficients, we can figure out which age minimizes subjective well-being. And if we use column 1 of table 2 with no country fixed effects, that minimum age is 47.76, 47 years and about 3/4. And for the regression in column 2 of table 1 with country fixed effects, the age minimum subjective well-being is just under 54 years. So the answer that we get for age at minimum subjective well-being is 50 years plus or minus a few years. And that's why we have the term midlife crisis in the paper, because that sounds like it could be something like a midlife crisis. But then things get better after that. Okay, so those are the tables, those are the results, and a couple more results are figure 1 and figure 2. And let's look at those. So these are now scatter plots that use the country level data set, and they just plot the mean of subjective well-being for each country against per capita income for the country. And that's the picture we get for figure 1. That's the and figure 2, it's mean subjective well-being against government consumption as a percent of GDP. And that's the figure that we get, and there's a little bit of discussion about interpreting them in the text of the paper. So those are all the main pieces. Then there's a reference list and sources of data, information about that. So that's the paper. Now, what does it mean to make this reproducible? The idea is that we should be able to put together documentation that will make it possible for a third party to come along and independently generate all of these results. So what are the results? Well, the results are Table 1, Table 2 with the 2 columns, Figures 1 and Figures 1 and 2 are also results. And then the last bit is these numbers are also results. We calculated those from our data. That's part of our computational output. So we should be able to reproduce these 2 numbers as well. So 2 tables, 2 figures, and these 2 numbers. So in our documentation, we're going to have to include the data sets that we started with, the Pew data and the World Bank data, just exactly as they were when we first downloaded them. And then we're going to have to include code that does all the steps required to prepare those data sets to merge with each other and then fix them up some more so they're all ready to be analyzed, and then code that executes the analysis and generates these results. So now let's go back to the documentation and see what all the pieces look like that are going to give us that standard of reproducibility. To explore the documentation for the midlife crisis demo paper, we'll go to the OSF page where the project is stored and scroll down and find the folder that has all the documentation. So this is the folder. So this midlife crisis SPSS, that's the project folder. That's got all the documentation in it. And let's take a quick overview of the documentation, and then we'll download this and explore it in more detail. But the quick overview is that we have a copy of the paper. That's exactly the paper that we just finished looking at. Readme File has some helpful tips for a user who's coming to this project and wants to reproduce the results using this documentation. The data appendix is like a code book for the clean, processed analysis data files that we use to generate the results. The data subfolder has 3 subfolders within it. The input data folder is where we have the copies of the original data files that are like the input for the study. This is the Pew Research Center survey data. That's the World Development Indicators macro level country data in their original form that we first downloaded them. This metadata folder essentially is information a user would need to know about these 2 data files. Basically, you want to have a code book for each original data set and some information about where the file came from. Now, what's in the analysis data folder? That, in fact, is empty. And the reason is that we're going to generate the analysis data by running our scripts. And we'll see how that works in just a minute. But this is the folder that is going to hold the final cleaned version of our data sets that we are going to use in the analysis to generate our results. But we don't have them in there because they're going to get generated by our scripts. And what's this temp folder inside the data folder? That's also empty. And that's just a place to put any intermediate data files that get generated while we transform these original data files into the analysis data file. Just if we need to store something temporarily, then bring it back later on, that's a place where we can just save it until we need it. Okay, so now the scripts are really the heart of the matter. These are what do all the work for us, really. Very briefly, these first 3 scripts do the job of reading the original data files, cleaning them up, merging them, and getting them exactly into the format we need to conduct the analyses that are reported in the paper. And So these three construct the analysis data files, starting with the input or original data files, and it's these scripts that are eventually going to save that analysis data in the analysis data folder. The data appendix script is going to generate all the output that goes in the data appendix, which is like a code book for our analysis data sets. And the last piece is the analysis script, and that is going to read the analysis data files, and then using them, it's going to perform whatever procedures are needed to generate the results that are reported in the paper. And we'll talk about this master script in a minute. That's a quick overview of what's in this documentation. And to work with it, I need to download it to my computer. So I'm going to select this midlife crisis project folder that has all the documentation in it, and I'm going to download a zip. And there it is, downloading to my computer. And then here it is in a zipped folder on my computer. And first thing I need to do is unzip it. And now this is the whole project folder. It's exactly what we saw on OSF. Nice thing about downloading folders from OSF is that all the contents that were in the folder are left intact. So the three documents that we mentioned are all there. The data folder with the three subfolders is there, and all the subfolders we expect and the data files we expect are there. In the output folder, we have a folder that's going to save output for the data appendix and a folder that's going to save output for the results of the paper. That's going to be generated by those results. The output that goes in these folders is going to be generated by our scripts. And here are our scripts. So let's start by exploring the first of these scripts, the import WDI. Here's that script in the SPSS syntax viewer. These comments at the beginning are quite important for understanding what's going on. So first, we're told this script is going to read the WDI data set. It's in an Excel workbook named original WDI.xlsx, stored in the data/input folder. And it's going to modify the WDI data to prepare it for merging with the Pew data. And then that modified data that's ready for merging is going to be saved in a file called Temp WDI, and it's not .dta, it's .sav, which is going to be stored in the data temp folder. So that's what this script is going to do when we run it. But before we execute this script, we have to be sure about two things. Everything has to be on my computer, namely that whole midlife crisis SPSS project folder and all the contents of it intact. But we just looked and saw that indeed we have the whole project folder and all the subfolders and files in them just as there are on OSF, so that's good. The second bit is that when we launch SPSS, the first thing we do before executing anything is making sure that SPSS's working directory is set to the main project folder, the Midlife Crisis SPSS folder, the main folder that contains everything. And why is it important that we set the working directory to that main project folder? Because in the scripts that follow, whenever we tell SPSS to go open up a data file, we're going to have to tell it the location where it can find that data file, and we're going to give it a path to find the folder with the desired file inside it that starts at this midlife crisis folder. So when we specify a path, by setting the working directory to the main project folder, that means every time we specify a path to SPSS to tell it where to go find a file, it's going to know that it starts in this main project folder. And we'll see concretely how that works in just a minute. But first, let's do what this instruction tells us. Let's go ahead and set the working directory to the midlife crisis SPSS folder. So I can do that with this change directory command, and I just specified the absolute directory path for my computer from the C drive through various levels of folders to that midlife crisis project folder, which I want to become the working directory. So that'll work just fine. I'll go ahead and execute that. And there was no complaint at all. Happily set that working directory. So now the thing is, this is not going to work on anybody else's computer. So what each individual needs to do, and this is explained in this note. For any other user to set the working directory to the main project folder, you've got to take out this directory path that works on my computer and substitute in the directory path for your computer that leads from the root drive to the midlife crisis SPSS project. So this is one thing that the user has got to do by hand. The user's got to get in here and edit that directory path. And that's critical, and nothing's going to run if the working directory is not set to this midlife crisis SPSS folder. And that's kind of special because the main principle behind all this documentation is that the user really shouldn't have to make changes to your scripts. The user should just be able to run your scripts without doing anything to them and automatically generate all of your results. So that's an important principle, and this is the one special exception we make to that principle. To get started, the user has got to get the working directory set to the right place. Okay, but so now we've done that. Whatever user comes along and puts in their own path can change the working directory to the midlife crisis SPSS folder. So let's see what happens after that. So just very briefly, this script has commands that do exactly what the note at the top said. It reads the WDI original data. It cleans and modifies the WDI data as necessary to prepare it for merging with the Pew data set. And I won't go through what all these steps are, but all of these steps are just for the sake of getting it ready to merge with the Pew data. And now we have this new version of the WDI data that's been cleaned up to get ready to merge, and we're going to save this temporarily. So we're going to save that modified WDI data, and that's what the temp folder is for in the data folder, just for temporarily saving things like this. So we're going to save it, and it's going to be called temp wdi.sav. So that's the overview of what this does. And the detail to point out is that when we ask SPSS to open up that data file, the data file we wanted was this file called original wdi.xlsx, but we had to tell SPSS where to find it. And this is a relative directory path that tells SPSS how to get there. And this is based on the fact that we set the working directory as the main project folder. So let's just look at the main project folder for 1 second. Here's the main project folder. And if I'm sitting in the main project folder, how would you tell me to get to that original WDI.xlsx folder? The path I have to go through is to go into the data folder and then go into the input folder. And then there I'm going to find original WDI.xlsx. And that's exactly what this command does. It assumes that we're starting in the main project folder. It says now go into the data folder, once you're in the data folder, go to the input folder, and in there you're going to find this original WDI.xlsx. And similarly, when we save this data in the temp data folder, we have to tell SPSS where to go to save this file. And again, say, well, we're always starting in the working directory, which is the main project folder. Go into data, go into the temp folder inside data, and then that's where we want you to save this temp version of the WDI data. Let's execute this whole thing. So the output that we get looks like everything ran all the way down through that last save command. So there were no hitches anywhere. And we should be able to look inside that temp folder. And that's where that temp WDI.sav was saved. So it's a good thing we had that empty temp folder there. So we had a place to temporarily put that WDI version of the data. So that's what the first script does. How about the next one? So I want to open up another syntax file. That's going to be the import pu. So we have the same notes at the top. Well, this is a different note about what this syntax file does. This reads the original pu data set, and that's in original pu.sav, which is in the data input folder. It modifies it to prepare it for merging with the WDI data, and then it saves the modified data in a file called temp.pu.sav, and that's going to be stored in the data temp folder. So this is an analog to the import WDI script. Same reminder about you've got to have the whole project folder copied onto your computer, and you've got to get the working directory set to the midlife crisis folder. So, and actually, because I set the working directory once, I don't need to set it again. So I'm going to skip over that. Had I not already set the working directory to the main project folder, I would need to do that. But now let's look at what this script is going to do. It's very similar. It's going to open up the original pu.sav, and we give it a relative directory path to tell SPSS where it's going to find that data file. Then it keeps some variables and does a whole bunch more steps of cleaning and getting it ready. And then once it's all ready to be merged with the WDI data, we're going to save that modified data in the temp folder, and we're going to call it temp.pu.sav. And in the save command, we have to use that relative directory path to tell SPSS that we want it to be saved in the temp folder. So let's see about running all of this. So that looks like that all ran. It got all the way down to the bottom where it saved that temp pu in the temp folder. We should be able to look in the temp folder, and that pu data ought to be there. There it is, temp pu data. Beautiful. So let's go on to our next script. And so I'm going to open up a new syntax file. That's going to be the processing. What is this script going to do? It's going to merge those two temp data files, the temp WDI and temp Q. It's going to merge them together. It's going to make some more modifications to that merged data set to prepare it for analysis. And then it's going to save two analysis data files. It's going to save an individual level analysis data file, and it's going to save a country level analysis data file. And the individual level data file is going to be called individual analysis.sav, and that's going to be saved in the data analysis folder, because now this is going to be the fully cleaned up, ready to analyze individual level data set, and the fully cleaned up, ready to analyze country level data set is going to be called country analysis.sav, and it's going to be saved in the data analysis, the analysis folder, in the data folder. So that's what this script is going to do. I'm going to skip over setting the working directory because I've already done that. And now let's look at what this is going to do. It's going to open up that temporary queue, and we have to tell SPSS the path to find that file to open it up. And it's also going to open up the temp WDI, and we have to give SPSS a path from the main project folder to where that temp folder is stored, and that opens that up. Then we do the few steps we need in the end to merge those two files together, matching by country. And then once we've done this, we've merged those two data files, and we do a little more cleaning up and generating some things. We generate some country dummy variables, and then once we've generated those country dummies, that's ready to be, that's the individual level data set all ready to be analyzed. So we save that. We call it individual analysis.sav, and that goes in the data/analysis folder. Okay, then we still have that individual level data set in memory, and now we're going to aggregate that to a country level data set. First, we have this get file command just to make sure that we've opened up that individual level analysis data set. And then we do the aggregation to get it to the country level. We do a little shuffle step here that's not too important, about a little temp version of that. But essentially what's happening is we're fixing up that country level data, putting labels on variables, labeling some values. And in the end, we have everything already to be analyzed at the country level, and so we save this country analysis.sav. It goes in the data/analysis folder. So let's see if we can run all of that. So there looks like there's some action. And let's look at this output, and it looks like we got all the way to the end of saving the country level analysis data. And up above we should see that it saved the individual level data. Yep, looks like it saved that individual level data. So we should be able to check and see that that's there. So in data, go to the analysis folder, and look, there they are, that we just generated. Now, So now, great, we've got the nice cleaned up analysis data files. So we need to do two things now. We need to generate the descriptive statistics and the figures that go in the data appendix. And we need to generate the results that go in the paper. And if we look at the syntax files we have, so this data appendix, that's going to generate all the output that goes in the data appendix, and this analysis is going to generate all the results that appear in the paper. And I'm going to just talk about this analysis syntax file. The data appendix syntax file works very similarly, but let's see how the analysis data file works. Okay, so what is this going to do? This script generates the results that are presented in the paper. And the results that we saw a while back, it's tables 1 and 2, figures 1 and 2, and the two estimated values presented in the text of the paper on page 4. Those ages at minimum subjective well-being, around 47 and 53, those estimates that we got. So those are the results that we want to reproduce. And there's just note here that some of these results are generated using the individual level analysis data set. And some of them are generated using the country level analysis data set. And this is a new part. The results generated by this script are saved in the output/results folder. And let's see how that works. Okay, again, we don't need to set the working directory again. But so we're gonna grab the analysis, the individual level analysis data and the country level analysis data. And then for each of the results in the paper, there's a section of this script that generates it. So here's table 1, and here's the syntax that generates the table, and here's the key thing. This is what is going to save that output into a file called table1.spv. It's going to go in the output results folder. So to get started, let's run just this bit, this first bit of this script. And whoops. So it looks like I didn't quite select everything, though I thought I did. So let's just see if that ran all of that. And we can tell by, let's look in the output folder to see, well, everything did run. So honestly, I don't know why we couldn't see that in the output. Oh, yes, I do know why. Never mind, small technical detail. But the point is, it ran, and it created that table 1, and there it is, saved right there. So now, this is nice, because we can compare this to table 1 in the paper, and this is exactly the table 1 that we looked at in the paper. So we have successfully reproduced that first result. And the rest of this script reproduces all the other results. So it's going to reproduce table 2, column 1, and saving the output in a file called table 2, column 1 in the output results folder. And then it'll generate table 2, column 2, and save it in the output results folder. It'll generate figure 1 and save it in the output results folder, and figure 2 and save it in the output results folder. And in fact, then the last two things that need to be reproduced are those two estimates of age at minimum subjective well-being. And so the first is to reproduce that number 47.75 approximately. And that's what all of this code is going to do. And it's going to save that. We call this in text one. So this is a result that's presented in the text as opposed to a table or figure. And that's going to get saved in there. And this last bit is generating that age at minimum subjective well-being for the regression with country coefficients. And that goes in output results in text 2. So let's try and execute all of this. We already did table 1, so I'll start with table 2, column 1, and everything after that. And let's see what we have now. So here's the output/results folder, and these are all the results that are shown in the paper. So this is pretty great. We've gone through it kind of carefully and slowly, but the bottom line is we've made it really easy now for anybody who comes along after us and wants to reproduce the results in the paper. They just go to the scripts and they run this one, and they have to take one moment at the beginning and first manually adjust that directory path to set the working directory to this main project folder. That's the one thing they have to do by hand, but then they just run this script, run the next two scripts. So these first three generate the analysis data, and then this script use the analysis data to generate all the results that are reported in the paper and save them in the output/results folder. So the data appendix script is just like the results script. It opens up the analysis data files, and then it generates all the histograms, bar charts, frequency tables, and descriptive statistics that go into the data appendix, and it saves them all in the output folder. And this time it all goes into the for data set subfolder of the output folder. So we run all of that. It looks like it finished, and let's just see now. If we go to this output for data appendix, that is all the output that you need for the data appendix. So that's pretty neat. So that's what. So that's all that the user has to do, and the Readme file is what explains that to the user. So the first thing someone should do when they come to this documentation, if they want to reproduce a study, the first thing they should do is read the Readme file. And this Readme file has two main parts. One is just a map of all the folders and subfolders and the files that are in them. This is just like what we went through at when we looked on OSF to see what was included in the documentation. But it's just nice to make a map of that so that your user knows what they should be starting with. And then there are instructions for reproducing the tables, figures, and results. There's an important note about setting the working directory. And once you've set the working directory, there are two ways you can reproduce everything. One is by executing the scripts one at a time, which is what we did. We executed script 1, 2, 3. We executed the results script. We executed the data appendix script, and that did everything. Just for the fun of it, and sometimes this is a real convenience, instead of executing all the scripts one at a time, you can execute one master script that calls all of the others, and runs each one in turn. So just by running that one master script, you can run all 5 scripts and reproduce all the processing, all the analysis, generate the results, generate everything for the data appendix, just by running that one master do file. So let's see how that works. How do you execute one master script and reproduce the entire study? To see how that works, let's go get our master script, which is the one that we named master.sps. There it is, and it starts out with a reminder about setting the working directory. And then these commands just call the 5 scripts in order. So this command means run, execute that import WDI script, and when you finish that, execute the import Pew script, execute the processing script, the data appendix script, and then the analysis script. The scripts in front of this is a relative directory path telling SPSS how to get from the main project folder to the scripts we're asking it to execute. But this then does the whole thing. If we select it all and execute, we'll let SPSS go through the whole thing. And it looks like it's finished. And so what has happened here? So in the data folder, there's the analysis data, and these were just created when we ran that master script. The temp data files are going to be there because they were created when we ran the master script. And all the output is going to be there. Here's the output for the data appendix. And here's the output for the results. Like there's table 1, for instance. And there's figure 1, for instance. So just by running that one script, we reproduced the whole thing. So it's automated and very user-friendly. And that's the model that we're trying to help students eventually reach. I want to stress that this example has a lot of pins and whistles in it, and you don't introduce this all at once to students. You start out in small steps, pieces of it, and slowly work up to something like this. And that's what we're going to be talking about for the rest of this workshop and the hackathon.